But if the system has unpaired electrons with transition metals or magnetic materials, one may need spin polarized calculations, and then codes are noticeably changed. And Sarah will teach us what to take into account if we deal with, if we eventually need to deal with spin polarized calculations if we go away from singles. Okay, Sarah, the floor is yours.
Okay, thank you, Dr. Kling. So as Dr. Kling said, I'm going to talk about the same procedure, but with the case of spin polarization. So firstly, we need the RR file, but which is kind of different for the spin up and the spin down. So we need to create another two directories, so called up or down or whatever you want. Then you need to copy the RR file into each directory, and you need also the par charge files in order to extract the dynamics for each of the spin up or the spin down. So after creating the partial charge files, as previously speakers explained, we need to execute this Perl script. Actually, we need to first copy it and then execute this. This script let us to extract the dynamics for the spin up and again for the spin bed actually separately. So before executing this command, you need to specify the range of orbital. So actually we need to modify the Perl script as I shown in the below. So just insert the desired range of the orbital here, and then launch the script by just type Perl and the name of this script. If everything goes well, finally you end up to two files. One is band out diff, the other is band out sum. Actually, I think diff means for difference between the alpha and beta, and the sum means summation of the alpha and beta. So in order to run the MATLAB code, as others said, we need RR file, band out diff, band out sum, energy pop, for master equation, and the name of the MATLAB code. Here, in this case, is Redfield spin up, for example. So in the MATLAB code, you need to specify the cell size, the z-step, HOMO, LUMO, and the range of orbital you want. So mostly we take the transition with the highest oscillator strength, which is the third column of the OS strength file. So and then you need to specify the transition range, like IH and IE for the HOMO, for the hole and the electron. So IH equal to 1 means the HOMO. If you change it to 2, it means HOMO minus 1. If you change it to 3, it means HOMO minus 2, and so on. For the IE equal to 1, it means the LUMO, and equal to 2, it means LUMO plus 1, and so on. So at the end, if your MATLAB code runs successfully, you will see the relaxation rate for the electron and hole, and two figures which shows the energy dissipation as a function of the time and the charge carrier distribution in the space in the right panel. So in this case, you can see that the hole relaxes faster than the electron. That's it. Thank you.
Okay, let me thank color. So any questions in the room, in online, or in the chat line? Sarah, may I ask?
Yeah, sure.
Oh, thank you. So from the first part of the talk until this slide, it looks like you need to have two directories with two data sets.
Yes.
So the part of the system with alpha spin, with spin up, and part of the system with spin down do not interact with each other and should be treated as independent models in different directories.
Exactly. Yeah, we need to repeat the process 2 times. One time is for the spin up, the other time for the spin down. And the files that you copy paste in each directory have different kind of material. For example, the RRR file for the spin up is different from RRR file for the spin down, as well as energy pop. Everything are different.
Okay, thank you. But your last slide, can you please go there?
Sure.
Yeah. It shows one green diagram for energy relaxation and one green diagram for distribution in space.
Yes.
Is it for spin up or spin down, or is combination of both? Like I was expecting to see a second set of images for different spin. Can you comment on this?
This one is just for the spin up as an example.
Okay.
So I didn't get your second part of the question.
And if you do similar, if you just keep going similar excitation energy for spin down, would it look same or different?
No, different. I think it should be different. Yeah.
Okay. So can you send to the chat line maybe link to your paper where you show the difference of spin up and spin down dynamics? Because it can be interesting for if someone is interested in seeing this difference, it could be valuable.
Yes. Just give me a second to stop share.
So while Sarah is making this, sharing the link, let's check if there are questions on spin polarized dynamics. If anyone is looking to discuss, or maybe I feel that Dinesh may ask what will be the specifics to make dynamics for triplets or doublets. Do you want to ask it to Sarah? Or is enough for now?
Specific question now.
Okay, yeah, okay. Okay. So let's count down. More questions 1, more questions 2, more questions 3. Many thanks, Sarah.
Thank you.
It brings additional dimension to all of our research. And the last but not least,